Hi everyone, welcome to the topic about probability distributions. Here are the learning objectives. Firstly, we're going to look at the characteristics of the normal distribution. Then we're going to talk about how we use the standard normal table, the Z table. And then we're going to calculate and interpret probabilities for a random variable that follow a normal distribution. First, let's consider the properties of the normal distribution. It's symmetrical around the mean, median, and mode. And I'll show you this on the next slide. It's bell-shaped, meaning that most values fall close to the mean and fewer values fall away from the mean. It closely approximates the population distribution for many random variables. Some of these variables I'll discuss with slide 5. Lastly, understanding the properties of the normal distribution is important because the assumptions of normality is necessary for much of hypothesis testing with quantitative methods, and so you really need to know how to test for this. Okay, here we go in understanding the properties of the normal distribution curve. You can visually see that bell shape. Notice mu, or the population mean, and how the distribution is symmetrical around this value. Also, technically, the tails of the distribution never touch the x-axis, the horizontal axis, but in reality this often happens at 6 standard deviations. That's 3 standard deviations either side of the mean. Lastly, the distribution is completely described by the population mean, mu, and the population variance, sigma squared. Okay, so what random variables do we know follow a normal distribution? The answer is so many, and that's why we're talking about the normal distribution. Here are some examples on the slide. I'll give you a few minutes to have a read. When you think about these things, think about that shape of the normal distribution. So for IQ, for example, the average IQ is 100. So most people's IQ is around that 100 mark, and fewer people are in the tails, being very low IQ or very high IQ. Okay, so here's some examples of 3 industries and the age of employees within each industry. Let's compare the normal curves. As you can see, industry A and B have the same standard deviation, but they have different means, one of 42 and one of 36 years. Now on the other side of the slide, let's compare industry A and C, where they have the same means of 42 years, but different standard deviations, and therefore the shape of the distribution is different. From slide 5, we discussed many examples of variables that are likely to be normally distributed. As you can imagine, there are infinite combinations of means and standard deviations for variables to follow the normal distribution. Thus, to calculate probabilities for the normal distribution, we must bring these means to a common language by standardizing the value and calculating what we call a z-score. The formula is shown on the slide. Note, by standardizing our data, the EZ, or the mean, becomes 0 and the standard deviation becomes 1. Therefore, our z-scores tell us how many standardized units our x value is away from the mean. A positive z indicates the value is higher than the mean, and a negative z indicates the x value is below the mean. The greater the number, the further away from the mean. The standard normal curve that is provided with your book, have a look in Appendix A, gives us cumulative probabilities. See the curve on the slide where the probability for less than z is given in the table. If we want to know the probability of a value greater than z, we would need to calculate this as 1, subtract that probability value, because the total area under the curve is 1. Please note that as a result of standardizing the data, the mean becomes 0 and the standard deviation becomes 1. So this means that z values less than the mean are negative and z values higher than the mean are positive. Here is an excerpt from your Appendix A. As you can see, the positive z values, which are z values to the right of the mean, we use the table on the left. And for the negative z values, which are values to the left of the mean, we use that table on the right. In this example, we have a z value of 1.52. As shown, your table will give you the probability to the left of this value as part of the cumulative probabilities. To get the probability of a value equal or less than this z value, we look to the positive z values, that table, and look down the left column to 1.5 and then across to get the second decimal place of 0.02. This gives us a probability value of 0.9357. If we want to know the probability of a z value greater than 1.52, we would simply calculate 1 subtract 0.9357 to get 0.0643. This is also shown on the slide. In this example, we want the probability of a z value less than negative 1.96. This time we look at the z table with the negative z values. Look down to negative 1.9, then across to 0.06 to get 0.0250. Okay, so in this example we want to determine the probability between two z values, specifically between negative 1.52 and 1.96. To do this, we calculate the probability for 1.96, then subtract this from the probability for negative 1.52, and that gives us the probability value in between. You can see this calculated on the slide. For this example, we use the tables in reverse, so that we're given a probability value and we need to find the associated z value. So say we want to know what z value corresponds to less than or equal to 68%. We look inside the standard normal tables and find a number close to 0.6800. In this case, it's 0.6808. And as this is the closest value, the z value that corresponds to this is 0.47. This then could be translated into an x value with the formula on the next slide. Here. One more thing to know about the standard normal curve is that there are certain probabilities that we observe with the shape of this distribution. Specifically, 68% of the data will fall plus or minus 1 standard deviation from the mean. 95% of the data will be contained within 2 standard deviations of the mean, and 99.7% of the data is within 3 standard deviations of the mean. This is known as the empirical rule, or the 68, 95, 99.7 rule. Lastly, here's an example for you to work through. Assume scores on a management test are normally distributed with a mean of 72 and a standard deviation of 8. What is the probability that a student will score above 60%? So first we transform the x value of 60 to a z value, which is negative 1.5. It's negative because the value of x, being 60, is less than the mean of 72, so that makes sense. It falls to the left of the mean if we think about the standard normal distribution. So we use the tables to determine the probability value. This value, if we look it up, is 0.0668. Because the question asks for the probability greater than 60%, we have another step to go, where we calculate 1 subtract 0.0668. And this gives us an answer of 0.9332. If that makes sense, you're on your way. Maybe also have a go at some of the additional exercises provided or those on Connect. This slide and the next are just to remind you about the standard normal tables, the Z tables, in the back of your textbook in Appendix A. Please note these will be available in your exam. Thank you.